This video is going to look at the process of dispersion. Now, dispersion is an application of refraction, so you should make sure you've watched the video on refraction before watching this video. So for this process, we're going to use a glass triangular block called a prism. And this experiment was done, and the significance of it was sort of demonstrated by Isaac Newton, who demonstrated that white light consisted of the 7 colours of the visible spectrum. So red, orange, yellow, green, blue, indigo and violet, which we know as the colours of the rainbow. So we're going to see how that happens. So first of all, I need a white light source, which is my ray box. And I'm going to, what's helpful when you do this experiment is to rotate your prism, first of all, until you get the result. Now, this doesn't show up amazingly well, but if I use this little screen to sort of show, hopefully you can see here that we actually have, from our white light source here, you can see that the ray is spread out, and on this side we have some red light, and on this side we have some violet light. Now, if I had a more intense light source, this would become stronger. And so what we're doing is we're splitting white light into the colours of the spectrum. And so we want to investigate this process. So usually what it's helpful to do is to rotate your glass block until you have this effect and then draw around it. But I know where the result is, so I've drawn around it to begin with. So what I want to do is, once I've got my result and I can see my light ray of light, just like previous, we want to draw where it comes in and out, okay? But what I'm going to do for this is I'm going to put my 2 marks on my ray of white light and also indicate where it enters the glass block. For my rays that come out, what I want to do for this experiment is I want to show what's the difference between the red and the violet. So I'm actually going to draw a line here and here to show where the red light comes out, and obviously it leaves the glass block at this point, and then this side and this side to show where the violet light comes out. Okay. At this point I can then move my glass block. So what I'm going to do is connect up my white light like so, and then from this point I'm just going to do the violet light still just in black, but just so you have a contrast with the red light. I'm just going to show it coming out with my red pen. Okay, so we have red light coming out here and violet light coming out there. We must make sure we put our arrows on for our ray diagrams. And now, before we can do anything else, there's a couple of things we need to add. So we need to add our normal lines, and we need to add a path to show how the light passes through the prism. And in this case, we can assume that the light passes in a straight line through the prism, because light always travels in straight lines. So we're going to bring that up and do an arrow like that. And then we need to add our normal, so we need our protractor for that. So we want to line up the 90 along the surface, like so, and then draw our dotted line that represents our normal there. And we want to repeat the process here. So again, we line up our 90 along the surface, because we must have normal lines that are 90 degrees to the surface, otherwise they don't mean anything. And so what we're interested in is measuring the angle of incidence and measuring the 2 angles here, the angle for the red light and the angle for the violet light. And you can hopefully see already, before I've even measured it, that the violet light has refracted more than the red light. The angle is greater. So first of all, let's just measure this angle of incidence. So we line that up on the 0 and we measure it, and so for that we get 43. So we've got an angle of incidence here of 43 degrees. And then for our 2 angles here, if I line it up, so for our red we are getting 53, and for our violet we are getting, I believe, bang on 60. Okay, so for this we have 53 degrees, and for this one we have 60 degrees. So you can see that violet light has refracted more. So the way we explain this process is by refraction. So as the ray of incidence comes into the glass prism, it is bent and changes direction. This process is refraction. Remember, refraction happens because the speed of the wave changes. So because it enters a more dense material in the glass prism, then it is caused to slow down, and that's what causes the ray to refract. And then when it leaves the glass block, because again it goes from more dense to less dense, it then speeds up again, which causes it to bend in a different way. So we can see it bending away from the normal again here. I could also measure these lines, the angles that it's actually come into, and you can see that these clearly are much smaller than the angles that they've left the block or entered in this case. So the reason that red light doesn't refract as much as violet light is down to its speed. So the equation for wave speed, so velocity for wave speed, is frequency multiplied by wavelength. So this symbol here is wavelength. And the crucial thing is that red light has a longer wavelength than violet light. Violet light has a shorter wavelength and a higher frequency. And so because each colour has a different wavelength and the frequency remains constant if they come from the same source, they each have a different wave speed, and because they have a different speed, they refract by different amounts, which is why they spread out. So this process is called dispersion. Dispersion is the splitting of light into the colours of the spectrum, and happens because of the difference in speeds, because of the difference in wavelengths between each of the colours.